Okay, so let's talk about what is alternating current, right? So alternating current refers to the current flowing in both directions lah. Like normally, when you learn about direct current in your AS, if your cell is connected this way, that means positive negative, then current will flow from positive to negative. But once you reverse the polarity here, so now it's this side is positive, this is negative, then current will flow the other way. So in an alternating voltage source, the polarity will keep switching from positive to negative, then switch from negative to positive. So when they switch, right, so current will go both ways. First, when it's positive, negative, it follow this way. When the polarity switches, then it also flows the other way. Now you need to understand, when the current flows through a resistor or a lamp, it doesn't matter which way current will flow, because you will still have power dissipated. Your lamp will still light up. So in most of the appliances or applications, it doesn't matter whether you're using AC or DC, except when you're using LEDs or diodes, because those are the components that allow current in one direction. Alright, and later on you will also learn about transistors, but not in A levels. So some of the devices, they will only allow current one direction, but others they don't really bother. So there was one recent past year, they asked you, right, why is it when you're using AC, the current will flow both ways, but why is there still power dissipated in your resistor or your lamp? Because your power dissipated, remember, is P equals I squared R. So whether your current is positive this way or negative the other way, when you square it, isn't your power still positive? So that's the idea lah. So it will still dissipate energy or dissipate power here lah, we say. Right. Let's look at the different types of AC. So these are the different types of AC that we can see lah in real life. One is a sinusoidal AC. This is the AC that we are supposed to get from the power company lah. Like in Malaysia we call it TNB. So they were supposed to give us sinusoidal AC. This one is a square wave AC. How you get square wave AC is usually when they convert from DC to AC straight away. The simplest form is just to keep switching the polarity. Then you will have DC here, then they switch, then you get the other way, then you switch the other way, that's why you get a square wave DC, AC lah. Because what they do is, they take a DC, just switch it over to AC. They just keep reversing the polarity lah. So these are the two we're going to learn in our syllabus. This other two is just to show you that there are also different types of AC, but we won't learn the calculation, whatever. Alright, like this is noise, this is sawtooth, so this is not in our syllabus lah. For a sinusoidal AC, we're going to start you off with that first. Okay, so for sinusoidal AC, the equation for this type of sinusoidal AC is V equals to V naught sine omega t, or I equals to I naught sine omega t. Doesn't it look familiar? Like, remember in your simple harmonic motion, we have X equals X naught sine omega t. But you see, in simple harmonic motion, if it starts on the middle, it's sine, start from the highest is cos, and then start from the lowest is negative cos. But for AC, you cannot see where it starts. Nobody can see electricity one, except current, you see some sparks and all that lah. But we will never know when it starts, so we just generalize everything in sine. So if you're using I versus T, then this graph will be like this. But if it's V versus T, that means if I replace the current with PD, or voltage, you will get exactly the same graph. And what does the V naught and the I naught here represent? Is the amplitudes. So if you are using I versus time graph, then this will be I naught, then this will be negative I naught. By using V versus T graph, then this will be V naught, and this will be negative V naught. So these points will actually represent the peak values. And what about the omega here? Now the omega here has the same meaning as in the simple harmonic motion. So omega represents angular frequency. So omega is also equals to 2 pi f, or 2 pi over period, which you can get from the graph because it's versus time, so you can get the period here. Or you can take 2 or 3 oscillations to get the period, no problem, or you can use it to find the frequency. Alright, so this is how you express the equation for AC if it is sinusoidal.